The largest of Saturn's satellites is a moon called Titan. It is enveloped in a thick atmosphere, one filled with orange haze. In 2005, a NASA probe penetrated the veil of mystery and sent back the first images of the surface. The terrain looked amazingly familiar. Black lines branched out over the surface. They looked just like rivers. And numerous lakes were discovered. This was the first time any celestial object had been found with liquid on its surface. The more the probe investigated, the more Earth-like Titan seemed to be. It was at this point that scientists began to suspect that life might be present.
Maybe in the seas, more interesting things happen. Maybe you get self-replicating chemical systems, much like those that are the first steps towards living systems that were deep in our own history. So Titan gives us a whole new set of possibilities.
There's the possibility that maybe there is life on Titan that has somehow found a way to make use of all of these building blocks that the atmosphere is making for it.
However, the temperature on Titan is minus 180 degrees Celsius. Could life really exist there?
Well, how do we know it's too cold? Imagine you're living on Titan and you're looking at the Earth. You'd say, oh, there's a liquid, there's organics, there's energy, but it's too hot.
Titan has both an atmosphere and liquids. Could life exist there? This planetary body, very similar to Earth. Saturn's moon, Titan. Imagine the journey from Earth to Titan. If you could travel at the speed of light, you'd pass Mars about 4 minutes into the voyage. At the 30-minute mark or so, you would pass the giant ball of gases known as Jupiter. Then, some 70 minutes after departure, you would finally arrive at Saturn, surrounded by those beautiful rings. Like Jupiter, Saturn is a large, gaseous planet. Finally, you'd reach Titan. With a diameter of 5,000 kilometers, Titan is about 3/4 the size of Mars. It's a moon the size of a planet. Fully cloaked in that orange haze, Titan's true appearance was not known until the 21st century. (1997) saw the launch of the Cassini-Huygens mission. The Cassini orbiter, equipped with cameras and other instruments, and carrying the Huygens probe, was sent to investigate Saturn and its moons, especially Titan. In 2004, 7 years after liftoff, Cassini-Huygens reached the vicinity of Saturn, 1.4 billion kilometers from the Sun. Cassini then proceeded to enter into orbit around the planet and its satellites, and to commence scientific observations. It took this image of Titan. For the first time, Titan's true features began to show from under that thick haze. The day was approaching when we would finally be able to see the surface of Saturn's giant moon. In December 2004, the Huygens probe separated from Cassini and coasted to Titan. The target landing site was near Titan's equator. What that site would be like, no one knew. Titan's atmosphere is 1,000 kilometers thick. The probe entered it. Huygens deployed a parachute and drifted down, jettisoning its heat shield. This image, taken from a height of 152 kilometers, was Huygens' first view of Titan, which was still obstructed by haze. Huygens was shooting still images as it descended. Its microphone also captured the sound of the wind rushing by. This was the first sound recording ever made of an alien environment. These images of Titan's surface were taken by Huygens from 16,000 kilometers up. Black veins, like the branchings of a river, are visible. It does look as though they are flowing to the mouth of a river. Now, from 8,000 meters above Titan, it looks just like the sort of coastline we're used to seeing on Earth. Finally, the landing. This is an image taken by Huygens just after landing. What look like rocks and pebbles strewn about over a flat plain are actually chunks of ice. The surface temperature is minus 180 degrees Celsius. Atmospheric pressure is a little higher than Earth's, 1.5 bars. The horizon seems blurred by mist. This is exactly like some rocky desert landscape on Earth. High above, the Cassini orbiter continued its observations. In the equatorial region where the Huygens probe landed, Cassini discovered a strange pattern. Some sort of regular striping. Further observations found similar striations covering some 20% of Titan's surface. Ralph Lorenz has dedicated himself to investigating this strange striped pattern. He is trying to solve the mystery of Titan's stripes by comparing them to patterns he finds on Earth. This is the Mojave Desert in the western United States. Lorenz believes Titan's stripes are like the peaks and troughs of desert sand dunes. There are indeed real similarities.
It's remarkable somehow that despite the different gravity, the thicker atmosphere, and the different material that the sand is made of, somehow the landscape ends up looking almost exactly the same as many places on Earth. By comparing the shape of the dune and the interaction with the rest of the environment, we can get an understanding of how these structures formed. And for example, different shapes of dunes form in different wind patterns.
So the goal is to solve the mystery of Titan's stripes by investigating terrestrial desert dunes. Lorenz's first step is to send up a kite with a camera for an aerial overview. He's looking for a place that has a striped pattern like Titan's. Next, he mounts a dune buggy equipped with GPS. He wants to measure the heights of dunes and the angles of their slopes. The shapes of sand dunes change by the minute. Lorenz plants a stake with a streamer attached. In fact, he plants a whole line of them along this slope. This will show what sort of wind creates this type of dune. The wind is blowing from screen left, across a gentle slope. Then it swirls around, as if to carve out that slope to the right. So it's become clear that here the wind flows from the milder slope over and down the sharper slope. Lorenz believes that the stripes on Titan are also wind-sculpted sand dunes. A closer look at that image of Titan's stripes shows ridges with milder and sharper slopes, similar to those in the Mojave Desert. So Lorenz conjectures that the wind on Titan must have been blowing from left to right. The winds blowing on Titan's dunes, however, are thought to be weaker than the winds on Earth. The reason for that is that Titan's gravitational force is only 1/7 of Earth's. A relatively small action can produce a big result. So on Titan, effects similar to those seen on Earth are being produced by mild winds.
Titan is still an active world where, geologically speaking, processes are still happening. And the fact that we can see sand dunes, for example, suggests that the winds that move the sand around are still active, that we're seeing a dynamic planet, much like the Earth.
There was another unexpected aspect to those images taken by Huygens. Look closely at those chunks of ice on the ground. They are reminiscent of stones turned over and over by rivers on Earth. Sharp edges are worn down. They're rounded, like pebbles. So there may well be liquid on Titan. This discovery attracted attention and astonishment. Meanwhile, the Cassini orbiter made a surprising discovery of its own. Black spots and blotches were visible near Titan's north pole. Radar observations showed them to be lakes, filled with some liquid. They number in the hundreds, and some of them are huge. This is the first time liquid has been found on the surface of any celestial body other than Earth. The lakes are dotted with islands and fed by rivers. But with a surface temperature of minus 180 degrees, any water on Titan would have frozen. What liquid could it be in these lakes and rivers? This is it. Liquid methane. On Earth, it's normally a vapor, but at extremely low temperatures, it condenses into a liquid. Methane melts at minus 182 degrees Celsius. It boils at minus 161 degrees. In the 20-degree range between those two extremes, it exists in a liquid state. The temperatures on Titan's surface are just right for liquid methane. Methane is composed of 1 carbon atom and 4 hydrogen atoms. It's the simplest hydrocarbon, and it constitutes the bulk of the liquid in Titan's lakes. A portion of the liquid is ethane, another hydrocarbon with similar characteristics. Scientists at the Jet Propulsion Laboratory are trying to determine how Titan's methane lakes were created by conducting experiments here on Earth. Christophe Saturn is an expert on bodies of ice found in the solar system. This device is called the Titan chamber. With internal air pressure at 1.5 bars and a temperature of minus 180 degrees Celsius, it reproduces Titan's environmental conditions. Inside is placed a disk of ice, standing in for the terrain on Titan. They then release droplets of liquid methane onto the surface of the ice. The methane disappears immediately, absorbed by the ice, like water being swallowed up by a thirsty earth.
So the big surprise, something we did not expect, is that when the methane falls on the ice, well, actually the methane got sucked into the ice. It gets absorbed. It doesn't run on the ice.
However, if methane continues to drip onto the ice, eventually it begins to pool on the surface. This suggests that wherever there are lakes on Titan, the surrounding ice must be saturated with methane. During its landing on Titan, Huygens measured the concentration of methane. That concentration gradually rose the closer the probe got to the surface. Then, the moment it landed, there was a sharp increase. It is thought that this was due to the heat from Huygens vaporizing the methane that permeates the ice. On Titan, liquid methane acts in ways similar to water on Earth. In June 2012, for example, Cassini observed a strange phenomenon near Titan's south pole. An oddly shaped mass seemed to be squirming about in the atmosphere. It was a cloud, swirling. A cloud made up of methane. On Earth, water is recycled as water vapor and rain. One of the factors prompting this is seasonal change. On Titan, the same sort of mechanism seems to be at work. Titan is tilted on its axis, some 26 degrees off vertical. The Earth has a 23.4 degree tilt. It's another point of similarity. Along with its parent planet, Saturn, not shown here, Titan takes 30 Earth years to orbit the Sun. The tilt of its axis gives birth to different seasons. At this location, Titan's northern hemisphere experiences the long days of summer. The northern hemisphere is warmed, producing rising atmospheric currents. Liquid methane on Titan's surface evaporates and is carried southward. Near the South Pole, it is winter. The methane gas is cooled, condensing into a liquid or even solid state. It can form clouds. Like that huge swirling cloud Cassini spotted. When it's winter in the northern hemisphere, the cycle reverses. Now the methane cloud forms near the North Pole. Underneath that cloud, methane rain begins to fall. Since methane is more viscous than water, its raindrops are larger, with diameters of about a centimeter. But as Titan's gravity is weaker than Earth's, the droplets fall more slowly, about 1 meter per second, like a soft snow on Earth. They soak the icy ground on Titan and form lakes. Wind blows, rain falls. When people could finally see Titan close up, they were astonished at how much it resembles Earth. In 2007, the Cassini orbiter spotted something truly peculiar on Titan's surface. A land formation some 70 kilometers across, in the shape of a flower. What could it be? Perspective can be gained by combining images taken from two different points of view. A three-dimensional image of the topography emerges. That strange formation turns out to be a rugged mountain featuring a 1,500-meter high peak. There's also a chasm that looks like it might be a volcanic crater. From that, one can infer a formerly active volcano. That volcano has been an object of particular interest to Jonathan Lunine, an expert on Titan's internal structure. He says that the volcano did not spew lava. Rather, it pumped up a mixture of ammonia and water.
One thing to remember is that when water is mixed with ammonia, it can stay liquid down to very low temperatures, down in fact to -100 Celsius. But at that point, within a few degrees of that point, the liquid is actually very viscous. It's almost like basalt. And so if that is what is flowing out on the surface, we would see very thick flows.
Lunine believes that under the ice beneath the volcano, there's an ocean. He came to this conclusion due to changes in Titan's shape. Titan completes its elliptical orbit around Saturn once every 16 days. During that time, it regularly feels the changing effect of Saturn's gravity. In short, it experiences tidal forces. At its farthest point from Saturn, Titan is almost perfectly spherical. But at its closest point, where Saturn's gravitational pull is the strongest, Titan grows fatter. Its diameter alters by as much as 10 meters. Lunine says that Titan can transform so dramatically because internally it is not made entirely of solid rock. Lunine's observations suggest the following picture of Titan's structure. The outer crust of ice is some 50 to 100 kilometers thick. The center is comprised of two types of bedrock. In between the ice and the rock, however, is a layer of liquid water. The bedrock generates heat, says Lenin, permitting the water to remain in a liquid state. This ocean layer is some 300 kilometers deep. Ammonia, present in Titan since its origin, has also dissolved into the water. It is thanks to this ocean layer that Titan can change shape so flexibly.
The interior is warm enough that really only liquid water is a suitable, stable material in that region. So we're pretty sure from the gravity experiment that Titan has a liquid water layer under its surface.
According to Lenin, the tidal forces caused by Saturn in turn stimulate volcanic activity. Tidal forces cause friction along the boundary between the ice and the subsurface ocean. The water heated in this way melts some of the icy crust. It builds up like terrestrial magma and eventually forces its way up above the surface. This ammonia-laden water flows out from Titan's volcanoes like lava. Lenin believes such volcanoes are proof of an underground ocean. Beneath Titan's icy shell, a whole new world lies hidden. Saturn has over 60 moons. Among them are Enceladus, ice-covered like Titan, and Hyperion, pockmarked with craters. Mimas has this huge crater. Those are just a few of Saturn's moons, but they all have practically no atmosphere. Only Titan boasts an atmosphere that extends as far as 1,000 kilometers into space. Actual measurements reveal that this atmosphere is 98% nitrogen. The rest is largely methane. Why is Titan the only one of Saturn's moons with a thick atmosphere? Solving that mystery through experimentation on Earth has been a preoccupation of Yasuhito Sekine. Sekine believes that Titan's atmosphere was generated by an extraordinary mechanism. The mechanism? Collisions with small celestial objects. Sekine is trying to reproduce that effect using a laser. When Titan was first formed, its icy landmass contained about 1% ammonia. So inside a vacuum chamber, a disk of ammonia water ice stands in for the young Titan. The laser beam enters from the left of your screen. It strikes a projectile, which then impacts the ammonia disk. That was the laser shot. Gases released by the impact are measured. One is nitrogen, released by the disintegration of the ammonia. Titan's thick atmosphere contains large amounts of nitrogen. According to Sekine's calculations, based on his experiments, repeated impacts by small celestial objects could have produced just such an atmosphere.
タイタンの地殻中にもともと入っているぐらいのアンモニアの量があれば今の 1.5 気圧の窒素の大気を作ることができるということを明らかにしました。 重要な点はですね、大きい天体でないと大気を重力的に持てないということです。なので他の衛星たちは同じように衝突は起きたんですけど、それぞれが小さいがために窒素の大気を持つことができなかったと。
For example, Enceladus, one of Saturn's other moons, is merely 500 kilometers across. That is 1/10 of Titan's diameter. Saturn's other satellites are also small, with weak gravitational fields. So even if they've been similarly impacted, they haven't been able to hold on to any atmosphere. But did Titan in fact experience repeated bombardment by small celestial objects? Hal Levison uses computers to calculate the history of the solar system. He has advanced the revolutionary theory that some 4 billion years ago, the entire solar system was shaken by a massive event. Levison argues that when the solar system was forming 4.6 billion years ago, Uranus and Neptune were closer to the Sun than they are now. He inputs the location and size of the planets, and also of the small celestial objects that lie further out. Then the simulation begins. At first, the basic situation did not change much. But some 600 million years later, Uranus and Neptune were suddenly flung to the outer realms of the solar system.
Then out, okay? And that caused the giant planets to slowly spread. It was infinitesimal, you wouldn't have noticed it, but the orbits were slowly changing. And that continued until Jupiter and Saturn got to the point where Jupiter was going around the sun exactly twice. Every time Saturn went around once, and that configuration is what set the whole instability off. Okay, so you went almost overnight from a time when, okay, there was a little bit going on, but not much, to this very violent period where all hell breaks loose.
The smaller celestial objects, shown here in green, had formed a ring at the outer edge of the solar system. But then the gravitational force of Uranus and Neptune violently scattered these objects. The result was that in the period from 4 billion to 3.9 billion years ago, the planets of the solar system encountered a barrage of small celestial objects. During this period, Titan also was hit repeatedly, developing a nitrogen-rich atmosphere. That made it a very special moon.
たった1億年とかそれぐらいの短い期間なんですけど、その間にですね、その 1.5 気圧という膨大な量の大気を作ることができたというふうに考えられます。タイタンっていうのはですね、唯一人類が初めて見つけた生きている天体だというふうに言えると思います。で、地球と同じようにですね、表面で液体が存在して、それが蒸発して雲を作って雨を降らしてというような循環が起きているのはですね、現在の太陽系の中では地球とタイタンだけです。で、その点において40億年前のその出来事というのはタイタンにまさに命を吹き込んだと、生きている天体にしたという意味で非常に画期的な出来事であったというふうに思っています。
1977 saw the launch of Voyager 1. Its mission? To explore and observe the outer planets, from Jupiter to Neptune. This was its view of Titan. It was a close look, but still the moon was shrouded in a thick orange haze. However, even then, one scientist maintained that the haze held the secret to sparking life below. Bishun Kare has been trying to penetrate the mystery of Titan's haze since the early 1970s. He participated in the Voyager mission. He has focused on the haze as being itself a source of life. Carré introduces a nitrogen-methane mix into a sealed flask to simulate Titan's atmosphere. The flask is fitted with electrodes. Now Carré discharges them. This is meant to reproduce the effect of lightning or other energy surges on Titan's atmosphere. It's about 10 hours since the start of the experiment. A reddish-brown substance has become visible inside the flask. Carré claims that this is the very same substance as the haze enveloping Titan. So what happened inside that glass vessel? First off, the electrical surges split apart the molecules of nitrogen and the methane. Their atoms recombine with carbon and other atoms in all sorts of ways, forming a variety of new organic compounds. Analysis showed that some 200 types of organic compounds had been created in this experiment. Organic compounds are the materials out of which our own bodies are made. They are the building blocks of life. It was thanks to Carré's work that Titan came to be considered one of the celestial objects on which life might exist. The Cassini orbiter's close-up observations of Titan have come some 30 years after Carré's experiments. Will they confirm that Titan's hazy atmosphere has in fact given rise to organics? The INMS is a device that measures molecular mass. Cassini has used it to determine the composition of Titan's atmosphere. Cassini's data were streamed back to Earth, where they were analyzed by Hunter Waite and his colleagues. Waite led the team that designed the INMS instrument package carried aboard Cassini. Waite's lab was able to reproduce and confirm Cassini's data by utilizing the same INMS system. They could then analyze accurately whatever molecules or compounds the instrument had detected. The results were astonishing. Rendered in the form of a chart, each of the different molecules identified by Cassini is represented by its own colored area. Various organic substances were created in Titan's atmosphere, ranging from ones with a single carbon atom to more complex ones with 6 or 7 carbon atoms.
When Cassini sent back data, we found out that the upper atmosphere was much more relevant than we ever thought, that most of the chemistry seemed to be going on in the upper atmosphere, that very large molecules were being created in the upper atmosphere, way beyond our expectations. Titan is one of the best organic factories in the solar system.
Bathed in ultraviolet and cosmic rays, Titan's upper atmosphere is continually engaged in converting nitrogen and methane into a rich array of organic compounds. As these compounds collect in the lower atmosphere, they produce Titan's famous orange haze. Finally, they are precipitated with methane rain onto the surface as well. It's been 4 billion years since Titan's atmosphere was formed. During that time, it is estimated the organics settling onto the surface have created a layer dozens of meters thick. The dunes discovered near Titan's equator are thought to be a large deposit of these organics.
Now on Titan, the sand is made, we think, from organic material, and we think that material comes down and gets built up into sand-sized particles that are then accumulated by the wind to form dunes much like these.
Amidst this accumulation of organics on Titan's surface are substances of vital importance to the emergence of life. That finding was made by a young researcher with a specialty in organic chemistry, Sarah Hurst. Hurst has undertaken a minute examination of the organic compounds discovered in Titan's atmosphere. She's written her own computer program to do that. Based on Cassini's observational data, she faithfully simulates the composition of Titan's atmosphere and produces the same organics. Next, she uses her computer program to determine the molecular structure of every compound.
These peaks right here are the masses of the ions in the mass spectrum data, and then it's the number of carbon, nitrogen, oxygen, and hydrogen in each of those peaks. And so then what the code does is it goes through and compares this information to a list that I've given it of all of the amino acids and nucleobases that we're looking at. So here we have, at 136, we have the molecular formula of adenine, which is 5 carbons, that matches. It has 5 nitrogens, it matches. No oxygen, and then 5 hydrogens. So we know from this that we have the molecular formula of adenine in this sample.
Genetic information for all life on Earth is encoded in DNA. Adenine is one of its 4 major components, or nucleobases, and all 4 have been produced in Hurst's experiments. If these nucleobases combine in such a way that they create DNA, then a huge step forward will have been taken towards life itself. With this discovery, speculation mounted that Titan might actually be capable of harboring life. Life on Titan? It may in fact already exist. If it does, what would it look like? The search is on for the answer. Trinidad and Tobago form an island country in the southern Caribbean. They have a population of about 1.3 million. They also have one of the most unusual lakes in the world. It's called Pitch Lake. It contains not water, but naturally occurring asphalt. It bubbles up from an oil field that lies underneath, creating a lake of asphalt that's 40 hectares in area and 80 meters deep. Strangely enough, Pitch Lake is the site of fieldwork being done by astrobiologist Dirk Schultz-McCook. He thinks that Titan is the best candidate for the location of extraterrestrial life. He's come here to try to envision what life forms on Titan might be like. Asphalt, like methane, is a hydrocarbon comprised entirely of carbon and hydrogen. You wouldn't think this was a substance that harbors life, but Schultz-McCook says it actually does contain microorganisms.
Well, this is one of the few environments where it's similar to Saturn's moon Titan, where we know that we have hydrocarbon lakes on the surface. Obviously, Titan is very cold, so it's still different than from over here. But we do have the liquid methane and ethane, which are also hydrocarbons. And if we can find out what kind of organisms are living here in the asphalt lake and how they adapt to living in the hydrocarbons, we think we can get some ideas to how life could operate on a moon like Titan.
Asphalt contains almost no water.
Did you say that there's microbes in there?
Yes, there's microbial organisms in that liquid asphalt.
In this thing?
In this thing, yeah.
Like maybe 1, 2?
Millions.
Millions?
Yeah.
Genetic analysis identified some 600 new types of microorganisms living in the asphalt. Most are archaebacteria, related to the primordial microorganisms that live in extreme environments.
So for them, actually, it's a great environment, it's a great food source, and basically a never running out food source because it's getting supplied from deep down there.
On Earth, there are microorganisms that can use asphalt for sustenance instead of water. Schultz-McCook is convinced that in Titan's lakes, there must be life forms that exploit methane in a similar way. Another scientist, Chris McKay, holds that the methane lakes on Titan contain creatures so unlike Earth creatures that they exceed our wildest imaginations.
Think of fish living in water and ask them to imagine a bird which lives in air. They probably can't conceive of an organism that is so much denser than the medium in which it lives. Fish move through water by floating. So they would imagine a bird must float in the air.
We humans live in an environment called Earth. We produce energy by causing oxygen and organic matter to interact. That is our lifestyle. But McKay is arguing that on Titan, life forms would be based on a Titan lifestyle that makes use of what's available on Titan. Titan's atmosphere contains minuscule amounts of hydrogen and acetylene. McKay thinks that there may be life forms on Titan that exist by deriving energy from the interaction of those two substances in a methane environment. McKay says that life could very well already exist on Titan.
So instead of being small and round, I would guess that a single-celled organism on Titan might be big and flat, like a sheet of paper, to maximize its contact with the nutrients in this thin soup. So it's living in an environment where there's not a lot of food. So it's got to access the food with big area, and maybe on this area it has active molecules. So it's like a big flat sheet of paper with little traps on it to collect food. To that life form, that will be the normal environment.
It was not until the 21st century that Titan's thick veil was lifted. Now that we're getting a closer look, what new discoveries await?
So Titan gives us a whole new set of possibilities, and there are for sure perhaps hundreds, maybe millions of worlds like Titan around other stars. Do those have life? Titan maybe can give us some clues.
If life is found on Titan, humanity's view of the universe will surely change.
The best place for me in terms of finding another type of life would be Titan. Because if we find it on Titan, then we know that it really is too. It's not the same as us. When we go to Mars, we may find life on Mars, but we won't be sure that it's not the same life as Earth. So my best hope would be we find life on Titan, because then I know that we found two completely different types of life. Then I can go on to some other science problem.
There is only one body in space that we know of, other than Earth, that has a thick atmosphere and lakes. Titan. If life is found on Titan, it will instantly increase the possibility that life exists in many other places in the universe as well. we may not be alone in the universe. We may have many comrades. The quest to find out for sure continues.
It's a place where few have gone, and most will never see. But that may all be about to change. The unimaginable is being engineered. A commercial ship to shoot people into space.
Can the public go to the moon in my lifetime? Can they go to resort hotels on orbit for their vacations?
Mass space tourism could be right around the corner, but it's an astronomically expensive and already deadly venture. Is this the beginning, or the beginning of the end? When it comes to innovative ideas, one man seems to have no shortage of them. Billionaire Richard Branson. His latest, a plan for the world's first commercial space liner. By his side is the ship's creator, legendary aerospace engineer Burt Rutan.
We are aiming a suborbital system to a low enough operating cost that it could eventually reach millions of people.
The men have dreamed of space tourism for years.
I'd seen the moon landing as a young boy. I assumed that one day I'd be able to go into space, and soon realized that governments were not really interested in you or me going into space. So in 1991, I embarked on a mission to try to find a technician or engineer who could build a reusable spaceship. It wasn't until I met Burt Rutan that I finally found the genius, the engineer that could make it all possible. I originally met Burt through my ballooning expeditions. I was attempting to be the first person to be able to cross the Atlantic in a balloon. And then on any flights that we attempted to try to be the first to fly around the world in a balloon. Burt gave a lot of useful advice in building capsules that could fly at 30,000, 40,000 feet.
We're at one hell of an angle. We're finding great difficulty actually getting the balloon to go down.
Branson never made it around the world, so he set his sights on space travel and put Rutan in charge.
Yeah. We won't have to put a barrier.
Yeah, okay.
So that's the idea.
Yeah,
and I'm
perfect.
sticking to it.
Yeah, no, that's good. No, that's great.
Burt Rutan is an icon in the aviation world. He rapidly gained fame in the 60s and 70s for his innovative approach to design. For over 3 decades, he designed, built and tested new aircraft at the startling rate of more than one a year. In 2004, Burt unveils Spaceship One, his entry for the $10 million Ansari X prize, a contest to spur space tourism.
So you're going to come on the horn after he touches down and say, "Show me the money," right?
Coming in 10 seconds, Brent.
Burt has designed a plane that can fly to the edge of the atmosphere, then drop its cargo.
Release. Fire.
Holy crap, that was close.
Pilot Brian Binney shoots out of the atmosphere and into outer space.
350, suggest shutdown. Roger, shutdown. Well, it's really quiet up here. Copy. Coming down.
The spaceship returns safely to Earth.
3, 2, 1.
Burt's team wins the civilian space race.
You are the man.
and the $10 million prize.
If I could please invite onto the stage Burt Rutan, the designer of the first private spaceship, Spaceship One. Burt.
Burt takes to the stage with his backer, Microsoft co-founder Paul Allen.
I was thinking a little bit about that other space agency. The big guys, I think they're looking at each other now and saying, we're screwed. Because I'll tell you something, I have a hell of a lot bigger goal. And you know what that goal is? I absolutely have to develop a manned space tourism system that's at least 100 times safer than anything that's ever flown manned to space, and probably a lot more. I have to do that.
Virgin Galactic Airways was born a week ago. 3 years from now, Burt has promised to deliver 5-seater spacecraft to take people into space, and hopefully it'll be the start of a lot of people being able to enjoy space.
They set up shop in Mojave, California, where Burt's company Scaled is based. Here, he assembles some of the world's youngest and smartest engineers.
The cool thing about Scaled that I realized day one is that there's this, this culture of really smart, amazing people.
Matt Steinmetz was leading engineer on the prize-winning Spaceship One. Burt puts him in charge of the Virgin Galactic project.
Sorry.
2-second snapshot
Of the flight. Across the board, it was a learning experience and a hell of a challenge. I mean, it's just, everything is big. It grew in size, and everything came along with it.
Spaceship One was only designed for a few test flights. This time, Matt's in charge of constructing a spaceship safe for passengers.
Different game than Scaled has ever dealt with. We've got to carry 8 people in there, 2 pilots, 6 passengers. So there's just a whole lot of depth to what does that really mean to building a spaceship, that you can fly every day.
To succeed, they have to do what only 3 governments have done before them: put human beings in space. The first hurdle: provide enough thrust to get there.
It takes about 2.5 times the power if you launch from the ground versus launching from an airplane.
They need to launch the rocket ship from a platform above 15,000 meters.
And you couldn't go to the rocket store and buy a motor.
So they have to design their own. They also need a way for the ship to re-enter the atmosphere without breaking apart or burning up.
Being able to do that and still be able to glide and land on an airport, that was the big aerodynamic challenge. 50 degrees. Did I say 50? So I set out to develop something that could be thrown at the atmosphere at any angle, and it would itself straighten out.
Well, pretty stable, huh? Nice and stable.
That's why we call her feathered re-entry, because like the little badminton shuttlecock, you can throw it backwards, but it straightens out.
Before Scaled tackles the spaceship, they need to focus on the carrier plane or mothership called White Knight 2. Lead engineer Bob Morgan is overseeing the odd-looking plane's construction.
And you've got the spaceship suspended in the middle, and you've got the 2 cabins here.
The team works for a year on electronics, hydraulics, flight controls, and the plane's one wing.
How'd that all work out? Where's your foam blocks at?
Today, they're installing the wing on its 2 fuselages.
A major milestone for the program. It's 140 feet span, and it's a continuous one-piece wing from tip to tip. So it pretty much fills this room minus about 10 feet on each end. Did y'all catch that?
Yes. Okay, here's the assignments.
On the left wing, we've got eyeballs, Zach and Steve.
You got Zach Reeder. This is basically his wing. It's his baby. He is the guy that built all the pieces and parts, so he's got a lot invested in it.
The wing itself is mine. You know, I invested the last year in this one part.
Boy, aft.
Okay, give me a little more.
If it bumps the tops of the rods, we're not going to freak out. I saw them all four go in.
Okay.
Home. Yes, our home.
It's a huge step for the team. In the Mojave Desert, things take a tragic turn.
The explosion happened just after 2:30 Thursday afternoon at a remote location at the Mojave Airport.
3 scaled employees are killed in a rocket test explosion. It's the company's first fatal accident.
We've had no injuries from anyone. And we've done some really dangerous stuff.
Bert loves his people. When the accident took place, you know, it hit him like nothing I've seen has ever hit anybody.
A bunch of guys out in the desert working, you know, just working. It's just a kind of a weird chance thing, and to lose your friends like that, people you see every day, it affected us all a lot.
Shortly after the accident, I was very sick for about 8 months, and I was out of the picture.
Bert, his health deteriorated just, you know, suddenly. It was a lot of chaos, a lot of turmoil. A guy like me, you know, I'd been here a long time, seen a lot of things. I thought, it's over. Not only did I lose friends, but I think all the great things that were scaled are done. So, you know, it was really, really, really hard.
A year and a half after the tragedy, the team is still pushing forward. And today they're pushing the mothership, White Knight 2, from the hangar to see if she can fly.
It's the big day. It's the worst day and the best day all in one.
For project aerodynamicist Jim Teig, this flight will test 4 years of calculations and design.
You got to figure out, you know, where you're right, where you're wrong, what assumptions you made were valid, which were invalid. The guys who fly the airplane are my friends, and I don't want to see anything happen to them. Ever. You know, so it's an emotional day.
White Knight 2 has never been wind tunnel tested, so the only way to find out if it flies is to take off. Peter Siebold heads up the test pilot program and is prepared to face the dangers of this first flight.
The objective is to get airborne as fast as possible and then enough power to prevent overspeed after liftoff. Planned test altitude 16,000 feet. If we're out of control below 10,000 feet, we're heading for the door. Chase, give us a reminder of what our altitude is if we're having troubles. I'll make the decision to head for the door. Clint, you get to the door, open it up, and I'll probably be pushing you out, so.
You've got to always keep that in mind. We're doing something that could conceivably kill somebody. And it sounds harsh, but you have to think about it that way.
They've designed and modified, calculated and recalculated. But it's a radical new design, and there's no guarantee that it'll fly.
I believe we've done everything we can to test this out, and hopefully it works.
All right. Thanks, Steve. All right, Steve, aircraft status.
Chocks go.
All right, go ahead and pull the chocks. I'm on the brakes.
Oxygen.
100%.
Altimeter 30.
All right, Clint, what do you say? I think today's a good day to go fly.
Let's go.
Chase, Scat 2-1 is rolling, taxiing into position and hold.
Chase copies. We'll get in position.
Tower, Scat 2-1 is taxiing into position and holding for Chase. Mojave Tower, Scat 2-1 holding short at 30, request takeoff clearance.
Mojave Tower, airborne pickups approved. Winds are calm, runway 30, cleared for takeoff.
Okay guys, have fun.
Will do.
Number 1, throttle.
Idle. Number 1, start. Power set.
There's 40.
50.
Good cross check. 60. 95. 100. 105.
Is that you doing anything with the rudders?
A little loose directionally?
Yep.
I was looking out the window and I'm watching the Earth go back and forth, at about this rate, thinking, I wish it wouldn't do that.
It was a split-second decision that the airplane was controllable or whether we really needed to bring the airplane back to the ground.
We've got some real poor centering of the rudder pedals at 0. Base from 2-1 on hot mic feels like might have pretty significant rudder lock issues.
I think they're going to get worse with altitude, but if he goes faster, it's going to get more pronounced. TC, make sure they watch their speed, and if they keep it slow, otherwise the forces are just going to get worse.
We're just working through how to control the rudders here. All right, Clint, we'll need to get your feet on the rudder pedals.
Back to scale.
And just whatever you do, don't get dynamic with it. Just keep your pedals, just lock them. Perfect.
We have what's called a reversible flight control system. It's a fancy word for meaning there's no hydraulic boost, there's no power steering. It's, it's as simple as a go-kart.
It's one of the largest planes ever to fly this way. The rudders are directly connected to the pedals under the pilot's feet, with push rods, cables, and pulleys. Balancing the forces of this giant isn't easy.
With this aircraft, you're right on the ragged edge.
Problem is they're just holding the rudders locked. The rudder still floats back there, and I can feel it.
The plane is unstable in the air, so the team returns to the airfield.
Just want to make sure you've got a good landing configuration. We're happy with that.
Challenges at the small deflections. It definitely feels like it wants to swap ends.
And now the next unknown, as they find out how she lands.
100.
Ten. 107.
3, 2 inches.
So we're rolling along and Pete says,
Okay, got nose wheel shimmy on the left.
Nose wheel shimmy, and I look out and on this other boom I can see the nose wheel and it's just shaking like crazy, just shimmying, vibrating all over the place.
It's still going.
No, I'm just going to get it stopped.
So I'm sitting there thinking, oh wow, I wonder when that's going to snap off.
The team anxiously waits as White Knight 2 wobbles to a stop.
The 2-1 is clear of the runway. Congrats, everybody.
There are problems to address, but it's still a huge success.
By the time we pulled up in the chocks and got out, Bert came to greet me and whispered in my ear, "We think it's the gear."
What I didn't realize until the flight was that the gear, when it's down, the landing gear, actually affects the rudder in a different way. I probably should have seen it before the flight.
This is a fabulous airplane. It showed its potential today. It's going to do its job very well.
We fought the hurdle of the accident with the rocket motor. We got through that. So really the next big one was, are we ever going to fly this gigantic airplane? So really now, you know, the focus kind of changes to rocket motors and spaceships. That's really the next big goal in my mind.
Only 450 people have been into space. The surface has hardly been scratched.
I looked at the big picture. I looked at what things could happen. Can the public go to the moon in my lifetime? Can they go to resort hotels on orbit for their vacations? 10, 20 years from now, we could start flying 100,000 people.
If commercial space travel can succeed, then anything is possible in space.
Rutan and Branson's vision for taking tourists into space is forming here, behind closed hangar doors.
All the buildings are numbered, of course, because we're not creative enough to think of real names. So that's 78. We're headed to 63.
Okay, let's go aft a little bit.
Are we straight on?
The team hopes that Spaceship 2 will be the first production spacecraft of the 21st century. This time, aerodynamicist Jim Tighe is lead engineer.
I worked at Boeing for 4 years, writing reports on wind tunnel data reduction and doing small corrections. And here I'm responsible for spacecraft. So this will be the lower skin, the bottom of that feather flap back over there. Tubes are hollow tubes which let you control pitch and roll. That's the master caution warning system. Hanging off this trailing edge are the elevons, which is the pieces over there. That's John Kruger in there. That big R2-D2 looking thing shoots a laser beam. So I'd get CLCD, CM all as a function of alpha, Mach, and feather in my case. So that's kind of neat.
Jim Tighe, you know, dreams in streamlines. He sees airflow, and when he sleeps, I don't know how he does it.
It's kind of hard to visualize it all, but it'll make sense once you see all the pieces start to come together.
Are we straight on?
Yeah, we're pretty good. Bert had a desire to make a bigger vehicle so the passengers could enjoy space and float around.
That's fine.
Jim's ship will have to fly at 4 times the speed of sound and withstand forces of up to 6G, which would tear most planes apart.
Okay, Clicos. Not too tight. Wait for the shot bags.
He's building it with carbon fiber composites, just fabric and glue.
You can see it's like a textile, right? It's just fibers running this way, fibers running this way. And along the direction of the fibers is where the material is strongest.
Made correctly, carbon composites are lighter than aluminium and stronger than steel. But one mistake could invalidate all of Jim's calculations and cause the spacecraft's feather to fail.
This is the upper outer right-hand boom skin. This is the last major part right here. Woo! It's hot in there.
We gotta have top of the tail out. More.
The new part is ready to be fitted into the spaceship's feather.
How are we on height back there?
The team is one step closer to turning Rutan's vision into a reality.
Houston flight is go.
T-minus 10, 9, 8.
Before Rutan's Spaceship 1, the only manned winged vehicles to go into space were the Space Shuttle and the X-15. There were tragic incidences involving both re-entering the atmosphere.
I was there at Edwards when Mike Adams was killed in the X-15. He re-entered the atmosphere in Crooked. It resulted in X-15 breaking up and him losing his life.
Bert's solution is to fold the spaceship in half, feather it, so it can drop back into the atmosphere safely, like a shuttlecock, without the pilots even touching the controls. It should slow the ship so quickly that heat buildup won't be a factor. Then the pilots will reconfigure the craft as a glider and land back on Earth.
Should we do this? Jim, you ready? Ready to roll?
Now the spaceship has to join the mothership in the larger hangar.
Over the track. Don't like about it, but just a little momentum's not bad.
Okay, now slow it up as we're coming out the door.
To keep prying eyes and cameras away, they move her at midnight, wrapped in black plastic, using only torches to guide the way.
Do you hear any pops or anything? It sounds good. It's quiet.
This is very interesting. There's like a whole herd of people just walking. It's like some pilgrimage or something.
3 feet that way. Your left.
We're in pretty good shape. I think put the mothership in the hangar. Spaceship's in here. We'll get it off the jacks. Yeah. Button up the doors and go home. I think we're doing good. Tomorrow the big fun starts. We made it. So this is symbolic almost in a way, moving to 75. Because there's no longer groups sitting here, there, and everywhere around the airport. Now it's kind of all starting to come together. You know, fight for whoever's in charge. So it should be fun. Yeah, and there it is.
You have to touch your airplane every once in a while and just, you know.
That's the only piece. Somebody's gonna.
She takes care of us.
People are starting to come out of the woodwork. It's kind of cool to watch people. They just stand back and look at it. Like they're in awe. So 4 years of your life building up to suddenly this thing becomes an airplane all in one day, which is weird, but it's cool. All right, boys and girls, gather around. So at the end of the day, congratulations to all you guys. This is awesome. This is your guys' vehicle. You did it, so kudos to you guys. You can't do this anywhere else in the world. I mean, you just can't do this anywhere else. From now until rollout, we just got to pull out all the stops. Thanks, guys. See you at 7.
See you at 7.
See you, Danny.
Aerodynamics finally takes a back seat to paint and graphics as the team prepares to reveal their creation to the world. After decades of dreaming of space, Richard Branson arrives in Mojave to unveil Spaceship 2.
Oh, it's a bit of wind here. Hi, bud. Hey, welcome back. You're looking really extremely well.
The partners in the space tourism program are reunited.
You couldn't have walked this far last time.
I was within a couple of weeks of just saying, I'm going to do something here.
Yeah. Oh, thank God for that.
I ended up having heart surgery maybe only 3 weeks after I was in New York.
Yeah. Oh, that's great.
Got it taken care of.
The friends take a look at the cockpit of the mothership that will carry both the spaceship and, in the other fuselage, the astronaut trainees.
I think that the passengers ought to be trained during a space launch. What you do is you go up and your wife is over there, I mean halfway to there.
Yeah.
Hello, have a nice flight. She drops off, the rocket fires, off they go, and then when they disappear, then you do your weightless training and your G's and you land. You can do it all in the same flight.
But Bert and Richard are already looking beyond short hops into space to fully fledged space travel, complete with orbiting hotels.
A space hotel can look like almost anything you want it to look like. Knowing Virgin, I suspect it'll be the shape of a giant V floating through space. I think the important thing about being in a space hotel is that you have massive windows, so you can actually look out at the universe around you and marvel at it.
But if you just have a bubble in several places on a big resort hotel, in which you can go in there and pull the curtain and just float around without the noise and the encumbrances, one of the benefits is these almost religious-like opportunities.
So we want to dream, and we want to try to make those dreams a reality.
I have to tell you that there is a lot of cool things that you get to do when you're governor. But I think that this here today is definitely one of the coolest things that I've ever done.
Ladies and gentlemen, welcome to Mojave Air and Spaceport, and welcome to the future of space.
You've seen the dignitaries, you met your heroes. I want to introduce the rock stars of the new space race.
Sexiest spaceship ever.
With the unveiling comes much celebration, but the world's first spaceliner still faces many tests. Spaceship 2 is scheduled to take to the air tomorrow for the first time.
We're at the very end of our day, so we're supposed to fly tomorrow. Okay, you got power on?
Tomorrow is really the start of the spaceship test program. We don't do any wind tunnel testing. We build them and go fly them.
The planes are wired from nose to tail with sensors that monitor stress and movement. Like a complex nervous system, they'll give the ground team critical real-time information.
This is our first chance to see if the predictions we make in a computer analysis match reality. You got to have the data going down to the ground station from the airplane in the air, so there's just all this stuff that's all tied together.
Okay.
Wes Purcell is in charge of the data transfer between the ships and the ground station.
When you're trying to meet a deadline and you're trying to get something as big of a milestone off as like a first flight in this for the spaceship, you know, it's like a deadline comes up and you don't want to be the guy that says, okay, my stuff's not working right.
But for Wes, that's exactly what's happening.
And we got to be done by 5 or else we're not flying tomorrow morning.
I did do one slight configuration change today, which I am seriously regretting now. So we did deviate from what we tested last night. And I knew it was a risk, and I took it, and it was a good one. So
I think it makes sense to get it as close to a pre-flight configuration as possible to work for everyone.
Ready? Anything? It's at 0 right now. There's Alpha. Talk to any telemetry engineer, and I think they'll tell you that that sometimes you get problems that you scratch your head over. You're not sure exactly what it is.
Tell me within 5 minutes and it's a miracle. Nothing impressive, but otherwise I'd say let's just.
We don't know what's going on. I'd say.
Let's just pull the plug.
Let's wait. I understand that it's not going to work exactly the way I want it to, but you still want it to work.
All that stuff. Yeah, we're going to knock it off for today.
So not flying tomorrow?
Not flying tomorrow. Okay. We're close. We'll go have a great day Monday.
Don't look so sad, Wes. Why not? We're not flying tomorrow.
That's right. Yeah, let's go.
Turn and burn.
5 days later, it's all systems go. Spaceship 2 lifts off for the first time.
we're going to do what's called captive carries, where you pick the spaceship up under the white night, you haul it up to altitude, you test the aerodynamics and the vibration, what we call flutter between the two airplanes. We'll smack the flight controls around to try to excite vibrations and make sure that it quits moving on its own.
1.1, 1.2.
What could happen? We could lose, Spaceship 2, White Knight 2, and three of our friends,
The team puts the mated spaceship and mothership through strenuous testing in the air.
The nose come down a little bit, good speed up.
5, 6.
Yeah, we don't do any wind tunnel testing. This airplane kind of is the wind tunnel test. God's wind tunnel is the big blue sky above us.
But these tests are preludes to the next trial of the program, the maiden flight of Spaceship 2. The attention shifts to the pilots taking the plunge.
I can't even estimate how many times I've thought through all the what ifs. Launching from 45,000 feet, you've got roughly 12 minutes.
2G pull.
We've got a significant problem. If you don't have good answers for what you're going to do in those situations, then you get scared.
Finally, test day. The team prepares for the first flight of Spaceship 2.
All right, good morning, everybody. It's time. We'll finish briefing here by 6, step to the aircraft, hoping to start it by 6:20 to make a 7 o'clock takeoff. We'll climb to altitude and drop when we're ready for it.
It'll be the first time that spaceship's flying on its own. It's a little scary. It's, my friends are going to be dropped in an airplane that's never flown before for 45,000 feet. Hopefully it flies right the first time, or right enough to get it on the ground safely.
Yeah. Oh, good. Nice to see you. Good luck. Exciting. Any concerns?
The only challenge is it's a short flight, so
yeah.
We've got to figure out how to fly it in a pretty short amount of time.
Yeah.
But
good luck. Thanks very much. Cheers. Yeah.
We've spent the last 5 years trying to design and build a flyable spaceship. It's the first glide flight, first no kidding flight on its own. Does it fly right, and can we, navigate, maneuver, and get back to home? So it's a pretty big deal.
Mojave ground, Scat 4-1.
Scat 4-1, Mojave ground, line clear, Hummy.
4-1, flight's ready to taxi. Loud and clear, taxi White Knight 2.
Taxi runway 30 and variable 4 altimeter 3016.
The first time an airplane flies, usually you take off just a little bit, and you get a little bit of daylight underneath the wheels and set it back down. With Spaceship 2, that's not an option because it doesn't have a propulsion system that lets it take off by itself. So the idea is actually to go as high as you can, which seems maybe counterintuitive, but it gives the pilots the maximum time possible to figure out how to fly the airplane, or if things are really bad, get out of the airplane.
At Mojave, it's time for the first flight of Spaceship 2.
And base, confirm still green for takeoff.
4-1, base, that's firm, green for takeoff.
Mojave Tower, 4-1's ready for takeoff, 30.
Runway 30, clear for takeoff.
Clear for takeoff.
Here we go, here we go.
70.
love it.
That was gorgeous, wasn't it?
I got tears in my eyes. Every time I see the thing, every time I see it go,
Wonderful.
You just well up.
We're going to go to a much higher altitude than we would typically fly a first flight. We'll be up near 45,000 feet.
Base, how's everybody doing down there?
We're looking good, 2-1 from scaled base.
Mojave Tower's got 2-1. 2-1 Mojave Tower, mission Montclair. Get 2-1, 3 minutes.
Scaled base is green for release. Elevons to go. Have a good one.
T-minus 60 seconds, waiting for arm.
Okay, base is giving us go for release, so I'll arm it at 30 seconds.
All right, you can arm it. 40 seconds. Beautiful day to go fly.
You betcha.
Okay, 30 seconds, here comes the arm.
Hello.
Okay, 20 seconds. Good luck, guys.
Will you guys please arm? We're not showing an arm indication.
10 seconds.
We are armed.
Okay. Okay, we're arming.
Okay.
Copy. 4, 3, 2, 1. Release, release, release.
Good release.
Okay, it's gone. All good, all good. Beautiful, beautiful.
I can't see him.
I can see it. Here we go. Shall I?
Oh, I see it. I see
Got it.
Okay, Caleb, pitch doublet.
Did I miss a pitch doublet? Has he done it already?
Yes, yes.
But turn hard left pitch. Turn sight Starship. Keep the turn coming. I'll follow you around.
He's a lot less nervous than we are.
Yeah.
He's got his butt on the line. God. Oh, man.
Good luck, guys.
Bert was looking for the Yahoo, it flies like a dream, best thing I've ever flown. And
326,000. Extra copy.
26,000 feet.
he's just waiting, and when you don't hear anything, you're worried that maybe he's struggling with it.
Come on, Pete, tell us how it flies.
Until some of these maneuvers were flown, you really don't know where some of the demons are lurking and whether or not we truly had a nice flying airplane.
148.
Slow it up to stall.
So on 15 Alpha.
Okay, 90
90.
knots.
Countdown complete. 93 min speed. What a beautiful flying airplane.
Hey, 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 hey! Woo!
Excellent day.
Woohoo!
Yeehaw!
You finally said it's a beautiful flying airplane. Oh, that's great. Beautiful flying.
Doesn't usually use words.
God, that's great. It's a good airplane.
Beautiful. Well done.
There we go, Tucci.
It's got a good airplane. Hot day.
On scale base, we are green for landing.
Well, this is one of the 3 real big risks.
Gear is out. Looks like all 3 are locked. Negative nose. Going to the emergency.
Chase from base. Say again, nose gear status.
Negative green on the nose.
Nose looks good from Chase.
Nose looks perfect from Chase. Very nice. 20 feet. 10 feet. 6 feet. 3 feet. 2 feet. 1 foot. 1 inch. Beautiful job, Pete. Go.
I can breathe now.
So a lot of really talented engineers who've, done the design of the airplane, and the folks who've put the airplane together are extremely gifted people, and I would trust them with my life. It was good.
That's cool. He's just checking things, I think.
Well done.
Yeah.
Good job.
Thanks, Bert. Super job.
Excellent. Fantastic.
Well done.
It was the best flying airplane. It was just amazing.
Wonderful. Oh, that's great. It looks so lovely.
Why didn't you tell us earlier? Pete was able to just kiss the ground with it, And when you do that, you've got and you've never flown the airplane before. You've never landed it. What that tells you is you've got a phenomenally nice flying machine.